Hello again. Today I'm going to show you a technique for standard additions with a single sample, but in this case keeping the volumes equal. It simplifies the calculations a fair amount. Sometimes it's extra work in the lab and sometimes it's more convenient, but it's definitely easier than some of the multiple volume type things we've seen before. In any case, let's go ahead. Manganese is usually added to steel at a level around 1/2 to 1% by weight. Increases the number of the good features of the steel's performance. So anyway, we're gonna look at how we might do this. So we start with about 1/2 gram of steel. We boil it in fairly strong nitric acid, make that up to 100 mils. We're going to take 2 aliquots. The first one, we're going to take that, add some potassium periodate. The exact amount isn't important. And we're going to oxidize the Mn2 plus to, it's actually permanganate, MnO4 minus, but that's manganese in the +7 oxidation state, and we're going to make that up to 100 mils. We measure that strong colored complex or ion at that number. We take a second aliquot and spike it using 10 mils of 100 part per million manganese. We add our potassium periodate, boil it, make it up to 100 mils and measure the absorbance here. So anyway, we set up a proportion, the absorbance or whatever instrument reading you're going to take of the unknown X is to the absorbance of the spiked X plus standard, as concentration in the unknown is to the concentration of the spike standard. So we can quickly calculate that. It's going to be equal to Cx, which is still unknown, plus 10 mLs times 100. Let's make it microgram per mil, divided by our final volume, 100 mils. And that's going to be equal to Cx plus 10 microgram per mil. We'll leave the units out for now for convenience. So now we can plug in our numbers here. Where are we? We got 0. What did I say? 371 is to 0.736 as Cx is to Cx plus 10. Now I'll let you do the arithmetic. This is basically just we cross multiply, get all the x's on one side and all the numbers on the other, and we get our Cx. This is in our final. That turns out to be 10.16. I'm going to keep an extra sig fig as a subscript there. This is micrograms per mil. Now, this came out of a first dilution, so let's do our Cx initial is 10.16 microgram per mil times 100 mils over 25 mils. Our dilution there, that second dilution. And that equals 40.66 microgram per mil. All right. Now I have to move a couple of things that you can't see but are getting in my way here. All right, so there we've got our initial. So like here we can put in the steel, we have 40.66 microgram per mil, and our initial digest was 100 mils. And that gives us micrograms, and it's 0.509 grams. And that turns out to be microgram per mil times mils gives us micrograms, microgram per gram. And that's 7988. That's microgram per gram or part per million. Let's convert that times 1 gram for every million micrograms, 10 to the 6 micrograms, and times 100 to put it as a weight percent, which is how we usually report it. And we end up with, well, let's go ahead and round it to 2 sig figs. And we got, whoops, I just erased the whole darn thing. Well, we end up with 0.80 weight percent Mn. I don't know what I touched there, but it sure wasn't what I wanted. Anyway, all righty. That is it for right now. And let me say bye for the moment. If I can get the darn thing out of the way so I can stop the recording.